How are you guys doing? It's Ashar here. So this is the second lecture of the series, which is on uninformed search. In this lecture, I would first cover all the basic terminologies. Then I would go on to explain different searching algorithms and strategies. First, we will start with the very basic searching strategy, which would be quite a common sense thing, and then we would move on to depth first search, and then we would move on to breadth first search, and then at the end we would move on to uniform cost search. Now, if you have already studied data structures and algorithms course in your university, it's highly likely that you already know what's a depth first search algorithm and what's a breadth first search algorithm. But I would still ask you to review it a bit in this video, because they are quite important. And the reason why I'm going to first take time to explain the terminologies in greater detail is because you will see these terminologies coming again and again and again till the end of the course. Like, you would see what's a transition model, a state, an initial state, what's a state space, actions, and all these things again and again till the last lecture. So it's important, and it's really important actually, that we understand them in detail before diving into this course further. So let's start with the first term, which is agent. Now, I have actually explained this in lecture 1.1 in extreme detail, so we have a great amount of idea about what is an agent. But just to review, its formal definition is, agent is an entity that perceives, or you can say it's an entity that sense its environments and then acts upon them. So yeah. Now, what is a state? So state is nothing but just a configuration of an agent in its environments. That's it. I'll show you with an example. So let's say I have this grid world. And initially my agent is here. So this is one particular state, right? Now, if I say that I have this new state, so yes, I have this new state now, and my agent is at a new position. So this is another state, right? And there can be a lot of states here, right? There can be 9 states in this grid world, because there are 9 places where my agent can be, right? So there can be 9 distinct, or you can say different states, right? So state is a very simple thing. That is it. Now there's another keyword, which is initial state. So initial state just means the state from which the searching algorithm starts. It's very basic. It's like, in this case, this is the initial state. Why? Because this was the starting point, right? So wherever wherever you have your starting point and your agent is at the starting point, that specific state would be your initial state, right? So let me ask you something. Now, if my starting point is here and my agent is here, this is a initial state, right? But if my agent has moved a bit, now this is not an initial state. Okay. We will actually talk in greater detail why initial states matter. So yeah. Now, the fourth one is, what is a goal state? It's pretty obvious. It's the specific state where where you know the state, situation, or condition that an agent wanted to be, right? Or in another words, the specific state, situation, or condition that an agent aims to achieve. Now I'll clear this a bit more. Let's say, taking our previous example, this was the starting point and this was the goal point, right? So if my agent reaches this goal point, then this is my goal state. That's it. Simple. This is super simple, right? If my agent is in the goal state, then then this is the goal state, right? This is the goal state of this grid world, right? So pretty simple, right? Okay, so let's talk about a little bit about actions now. So actions are just choices that can be made in a state. Now, giving you this example again, if my agent is here, what are the choices available to it to move, right? It has the choice to go left, it has a choice to go it's actually upwards, it has a choice to go upwards, it has a choice to go right. So these are the two options, right? Now if my agent, instead of being here, if it was here, then it had an option to go up, it had an option to go left, it had an option to go right, and it had an option to go downwards, right? So these are all different actions, right? These choices are nothing but different actions that it can take. So if an agent takes this choice, right, and it actually ends up here, right, it ends up here, then I will say it took the right action, right action, like towards the right, towards the right. If it would have moved upwards and it was here, I would say that it took the towards up action. That's it. Super simple, right? So let's talk about a transition model. Now this is a bit confusing, but it's pretty easy to explain. So it is nothing but a description of what state results from performing an action in a state. Now I'll just explain you with the same example. So this was the state that we were on initially, right? And we took this action to go right. So it went here. It came up with this new state. Now this whole thing that we saw here, the initial state and the action that we gave it and this new state that it generated, this whole thing is called a transition model. As simple as that. Nothing to be confused about, right? So that's it. It just contains of an initial state, it contains of an action, and then it generates the next state or new state where it ends up after taking this action. So this whole thing is transition model. That's it. So let's talk about state space now. So state space is extremely simple to understand as well. It is just the set of all states reachable from initial state. That's it. So if I give you an example about this, so what would be the state space in this example? If I remove all this, what can be a set of all the states in this thing? There can be a state where the agent is here, right? There can be a state where the agent is here, there can be a state where the agent is here, 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 everywhere, right? So there are 9 different states. This set of 9 different states is called state space because it contains all the different states, right? It contains a state where the agent is only here. Contains a state where the agent is only here, and so on, right? So it is just a set of all 9 different states in this case. But if I give you another very short example, so let's say we have a 2 by 2 grid. So an agent can be here, the agent can be here, the agent can be here, and an agent can be here, right? So these are the 4 different states possible. So the set of all these possible states are called is called state space. But there is something that we are missing here, and it's extremely crucial, and that is it said possible states from the initial state, and this is extremely important to note, and I'll give you an example now. So let's imagine we have this big state, or sorry, big grid, and it also has walls in it. It also has these walls in it. And the thing is that the agent cannot pass through these walls, right? It cannot pass through these walls. So if I ask you that if my agent is here, and this was my initial state, this was my starting state, right? And now my agent is here, will this specific state be included in the state space? The answer is no, because this is not possible. It is a state in itself, but it is not a possible state given that this was our initial state, right? Like it cannot possibly reach here at all. It cannot possibly reach here. Why? Because it is all covered with walls, and we cannot pass through walls. So really simple thing. It's just the all possible states from the initial state. Now an interesting example would be, let's say this was my initial state, this was my starting state. Now look at the difference. Now this would be this one state would be my state space. Why? Because I cannot go here or anywhere, right? Because I am covered with walls, and this is my starting or initial state, so I cannot go anywhere, and so this can be the only state. And if this is the only state, then this is also my state space, right? So it is a set of possible states from the initial state. That's it. Super simple. Okay, so now let's talk about goal test. Now, goal test is a condition that determines whether a given state is a goal state or not. And there is a very simple way to understand this. And that simple way is, imagine this is my grid. And this is my goal state. This is my starting state. And let's say this is my indexes or numbering of this grid. So if I ask you, where is the goal state, or if I ask you, how do I know this is the goal state, what is the condition that it is matching? It's super simple. If it is on the 0 by 0 coordinates, which means if it is in this state which is on 0 and 0, where the xy is 0, then it is a goal state. So in my program I can write that if the states xy coordinates are equal to 0 comma 0, then it is a goal state, right? So this condition that I wrote, this is called a goal test. Now in grid world, this is specifically that if you are having a very different world, then it can be different, but it's something super obvious, right? It's not something out of the world, so do not get too confused about it. It's mostly the location, right? The location was this thing here, 0 comma 0. That's it. So now let's talk about path cost. It is a numerical cost associated with a given path. So if let's say I have this node or graph and I have this way, and I say if you want to go from A to B, it will take $5. If you want to go from B to C, it will take $10. And if you want to go from C to D, it will be $1. So this path cost of from A to B, the path cost from A to B is what? It's $5, right? And if I ask what is the path cost from B to C, it is $10. But if I ask you what is the path cost from A till D, now check this. First from A I'll go to B, right? Because that is the only way. So that I spent $5. Then from B I'll go to C, that is the only way, so I'll spend $10. My total cost is 15 now. And then from C to D, that is the only way to go to D, I'll spend $1. So what is the path cost from A till D? It is $16. Okay, as simple as that, nothing else. Okay, so that's my path cost. Now let's talk about what is a solution. Now solution is a sequence of actions that leads from the initial state to the goal state. A simple, very simple example can be, let's say I'll take these things again. With a bit of a twist. So this is A, this is B, this is C, this is D. Right? Now let's say the cost from going from A to B is 1, this is 1, this is 1, this is 1. It's same, it's uniform cost, right? So if I say what is the solution of this problem of this graph, given that A is the starting point, A is the initial state or starting point, right? And D is the goal state or goal point or node, right? So you will say, okay, Asher, the solution would be I'll start from A, I'll go to B, and then I'll go to C, and then I'll go to D, right? This can be a solution. I can reach from A till D, right? So this is a solution. This is my solution, that's it. Now, one thing that you might have noticed is there was another thing. When I went from A till B till C till D, the total cost was $4. But if I go from A to B, from A to B and then directly D, then my cost is less, right? It's 3. So these both of these things are solutions. Both of these things are solutions. Both of them. They are correct solutions. But this one is the optimal solution. Why it is optimal solution? Because it took you lowest path cost, right? This was the cost of this path was $4, the cost of this path was $3. So this one is better, right? This one is the most efficient. So this one is the optimal path. That's it. So optimal solution is a solution that has the lowest path cost among all solution. So this is the optimal solution. This is the optimal solution. That's it. Now let's talk about this node. What is a node? Now, if you haven't studied data structures or even basic programming, you might not know what is a data structure even. But the simplest way you can understand is it is something where we store data. Something where we store data. That's it. That is a data structure. We use it to store data. Now, if I say, okay, what is a bottle and what is a, let's say, this big can sort of thing, these both store water, right? But this store it in a different way, this stores it in a different way. It seems that thing that we have different data structures as well. We have data structure called arrays, queues, linked list, and so on, and stack, and different things. So that's it about data structure. So a node is nothing but a data structures that keep tracks of the following thing, or you can also say it is a data structure that stores the following things. Now what does it stores? It stores the current state. What state am I in currently, right? It stores the parent state or the parent node, like what was the parent where I came from. It stores an action. What action did the agent took when he was or when it was in my parent state? What action did it took to reach me? It stores that action. Okay, and then at last it also stores the path cost. Now note that this path cost is the total cost from initial state to this current node. It is not just the cost of going from parent to child or current node. this is the complete cost from here till here. Okay, so it is the total cost. So these are all our terminologies, and I hope that you understood these well. So this would be the lecture number 2.1 on terminologies, and now in lecture 2.2 I'll move on to searching. So see you next time.